Okay guys, so I just thought you might want a bit more help on this uniformly accelerated motion business. So look at this scenario here. We've got a ball that's going to be kicked with a velocity of 10 meters per second in this horizontal direction, and it's going to fall a distance of x here. So I want to know how far the ball will travel if this height of this cliff is 30 meters. So it looks like we haven't got very much information here, but look at the equations we've got already. We know these three equations, 1, 2 and 3. So can we use equation 3, v equals u plus a2? Well, I'm not even sure what I'm trying to find out, really, am I? I want to know how far it will travel. Well, there's no distance in this one, so there's no point using equation 3 because it won't tell me a distance. But this is where this is tricky, because I already know the velocity in the horizontal direction. Yeah, it's 10. And I know an equation from key stage 3, which is velocity equals distance over time. And I can rearrange that to find x v times t. So you might think, well, that's easy. I'll just find a time. But what time? So you have to think about how long the ball is in the air for. So let's look at the trajectory. The ball is going to do this. So there's a horizontal component. If I look at any part of this flight here, there's a horizontal component there, which is 10 meters per second. And there's also a vertical component here. And this vertical component is dependent on the gravitational pull. So this is a constant velocity, and this is an acceleration. So the velocity is changing. And I think you can probably see that as we get further and further, it's falling for longer, it will be traveling faster. So this arrow should be getting longer as time progresses. That's why we get this arc. So we've got two types of motion here, a horizontal component, which is constant, and a vertical component, which is getting bigger and bigger as the ball falls, okay, because it's accelerating due to gravity. So we need to find out how long it's in the air for, and the easiest way of doing this is to use equation 1. We have x equals ut plus half at squared. Now u is the initial velocity of my ball, but it's in the direction of the acceleration. And I think you can see this ball here, the initial velocity has no velocity at all in the direction of the acceleration. It has got a velocity here, but that is not in the direction of the acceleration, which is down. So we can rewrite our equation here for x. What I'm saying is 30, so we got 30 is equal to the initial velocity of 0 times t, well, that's going to be 0, plus 1/2 of at squared. Okay, now a is 9.81 and t is t squared. So we just do the maths. So 2 times 30 is 60, divided by 9.81, and that is equal to t squared. So if we square root that, we get t. So 60 divided by 9, then square rooted, well, to work it out a calculator, is 2.47 seconds. Okay. Now it's an intermediate calculation, so I can leave that to as many significant figures as I like. But we need to round to 2 sig figs at the end, because I've only got 2 sig figs here and 2 sig figs there. So that's the time, and then we can just use this equation here then. So the distance it travels is my velocity, which was 10, times 2.47, and you don't even need to calculate for that, do you guys? So it's going to travel 24.7 meters to 2 sig figs, that's 25 meters. And remember, we work to the lowest number of significant figures given in the question, so 10 is to 2, 30 is to 2, so my answer must be to 2. Again, I hope this helps.